Okay, let's continue. Let's finish our section of the 8.2. And the next algorithm question I want to talk about is the anagram. And if you don't know the concept of the anagram, that means that if we grab one word and then we shuffle all the letters a little bit and then we put them together, and that is another word. And for example, cinema. And if we shuffle the letters in cinema and put them into a different order, and you can see we can put them into Iceman. And why? Well, there are, if you do a Google, there are a lot of the anagrams examples. Well, I prefer this one because the Iceman is one of my favorite character in the X-Men series. And our goal will be, we have two words. So and then it's guaranteed that those two words are having the same length. And the question is, how do we verify whether they are anagrams or not? Well, and the first way we want to talk about is, of course, the worst way, and this is the brute force way. And the goal is, the approach will be, we grab the string one, and then we shuffle the letters exhaustively and come up with all the possible solutions, all the anagrams possible using all the letters in string 1. And then we want to check whether string 2 is one of them. Okay, so that's ugly, right? And this is definitely it's a worst solution. Well, and if but the solutions to get this done is actually easy because in Python we have a built-in function called permutation. So this can do exactly what we are trying to do in the solution one. And the question is, well, coding this is super easy. But my question is, what is the time complexity? So, well, we can answer this question in another way. That is, how many permutations are there if we have the string one? If we have the string one and the length of the string one is n. So that is n multiplied by n minus 1 multiplied by n minus 2 and etc. So what's that? That is n factorial. So this means to answer this question using the brute force way, we have to come up with n factorial permutations before we can check whether string 2 is one of them or not. Why is that? Because you see that it's n factorial. And where is n factorial? So if you see this plot as the possible time complexities, and you may say, no, there's no n factorial. And where is it? It is even here. So it is among the ones grows the fastest. So it's even worse than 2 powers n. So n factorial, that's really, really bad. So we don't want that. Okay, and the second one. So the second one, well, I don't have a whiteboard, so let me try to write here. So I'm going to do cinema and ice man. Okay, and then the process will be, well, we want to visit all the characters in this the first string one by one. So we see C. Okay, and then the next step what we want to do is we want to go to the string 2, and then we want to visit all the letters one by one. If we see the first C, we check off that. Say, well, we want to have the C, and then we scan the string here, and then we see, okay, I see a C, and then I want to check it off. And how can I do that? I want to replace that with a special character, and for now I'm using the underscore. Okay, so this means C is here. C is in the first string, and then I've checked C off in the second string. So move on, and then I have I, and then I is here, so check this one off. So far so good, because for first two letters, I'm able to find them and check them off in the second string. And then how about N? So for the N, and then I scan through that, and then I see the N, I check it off. Okay, so well, the process will be for each of the letters in string 1, I want to go and scan the string 2 and then check it off. Well, the question is, when do we stop? There are several possibilities. And number 1, if we have a letter, so if we have the letter X here, and then we scan the string 2, we didn't have the X. What does this mean? This means in the string 1, there is a letter we cannot find in the string 2. So this has to stop, right? And what else? If we have the X in string 2, what will happen? This means, well, when we are scanning through all the letters in string 1, and then after that, in string 2, we have a leftover. And then again, there's a unchecked value in string 2, and then we have to finish. Okay? And another question will be, so how about we have a C here and a X here? So let me put here, Iceman. Okay? S-man X. Okay, so for the C, the first C, we check it off, no problem. And then for the I check it off, no problem. And N, check off. And N, E, check off. And M, check off. A, check off. So eventually there will be another C. Okay, so in the final letter C, I want to scan, and then the only leftover letter is an X, and then I can't check that, so I'm doing a second round of a search of the letter C, and then I cannot find that, and then I have to stop. Okay, so well, this solution is kind of complicated, and if we want to see the code, and you're gonna see I'm using a none. So if that letter is found, and instead of putting a underscore, this solution uses a none, saying, well, okay, that letter has been erased. Okay, and then there is one iteration. The first iteration will go through all the letters in string 1, and then inside there's another iteration, and that iteration is doing the search in the string 2. So if the length of the first string is n, the length of the second string is n. And what do you have? That is a n round iteration inside another n round iteration. So tada, that is a O n square, right? So well, considering the first solution is a n factorial, and I would say, okay, it is already a success, and then we lower that to n square. Okay, and then the next question will be, well, how can we do that even better? And here is another idea. Okay, let me get rid of this box. And then I want to add a new box here. So the idea will be, again, let me use the C name and Iceman. Okay, well, and the plan will be, how about we sort all the letters? Okay, so C, A, C. Okay, so this is all the letters sorted, right? And if I want to do the same thing, and then I also got this one, all the letters sorted from A to Z. Well, and why am I doing this? Well, the cool trick is, if we are able to sort the string 1 and the string 2, now we know all the letters are sorted from A to Z. And then if those two sorted strings are the same, what does this mean? Two sorted string, exactly the same. This means they are anagrams, right? Okay, so go ahead and try to write the code here, and we want to do we want to first apply a trick. We want to force a string into a list of letters. So it should be like this. So for the string cinema, you want to first put it to a list like this. So C, comma, I, comma, N, comma E, comma M, A. Okay, so you first want to put the cinema into a list like this, and then you want to have this list of single letters sorted. Okay, so this will be your plan, and then after you got those two lists sorted, and then eventually you can compare those two lists and see if they're exactly the same. And after you finish the coding this part, and we can resume and talk about the time complexity of this one. Okay, so I'm going to stop this video here, and I will talk about my solution in the next video.